So today we covered the difference coefficient, and since I don't think there were any lectures on that, I thought I'd go ahead and do this so you'd have some resource to look at. So, the difference quotient is f of a plus h minus f of a divided by h. Now, we did one where we had x. You can have x plus h minus f of x over h. The only difference is a is a particular value of x. Here x is just a general x. And again, the whole idea here is this is the equation that we'd find in calculus that we would use to calculate the slope of a curve that's not a straight line, or even the straight line. It would work for that as well. So we have to know how to evaluate f of a or f of x and f of x plus h or f of a plus h, which we did in class. So I'm just going to work through an example. So let's say f of x is x squared plus 4x plus 10. So we already know what f of x is now. So the only thing we need to put together the difference quotient is to see what f of x plus h is. So, this term in the parentheses is what we substitute in for x in the original function. Now, if it was just x by itself, it would just be the original function. But here we have x plus h. We could have a plus h. Doesn't really matter. So we use these parentheses to put the term into the equation. So instead of x, I put x plus h inside parentheses. Instead of x in the original equation, I put x plus h in parentheses. Here, I don't have an x, so I just write down what's in the original equation. Now, we could go ahead and multiply this out before we substitute it in, or we could just substitute it in this way, and then that doesn't really matter. So I'm going to go, just in terms of space, I'm just going to multiply these things out. So again, this is one of these x plus something. So it's squared, doubled, squared. So this term here is going to become x squared plus 2xh plus h squared. So that's this multiplied out. This, we just distribute the 4 to each term, so we get 4x plus 4h, and then we bring down the 10. And that's pretty much it. Okay, now we can plug it in. So we're going to use the f of x plus h minus f of x divided by h form of the difference quotient. So for f of x plus h, I'm going to plug that whole thing in. So I get x squared plus 2xh plus h squared plus 4x plus 4h plus 10. So that's this term here. And I'm going to subtract f of x. First, I'm going to move this over so I have some room. So I'm going to subtract x squared plus 4x plus 10. Divide the whole thing by h. Now, as I said in class, the terms that don't involve x are going to cancel out. So here I have x squared. Here I have negative x squared. Maybe the best thing to do is to, I know it's a lot of extra writing, but just so that you see exactly where these things cancel out. So what I've done is I'm going to distribute that negative to each one of those terms. So it's going to be negative x squared minus 4x minus 10. So that's this, all divided by h. So now let's circle this cancels out with that. This in term doesn't involve h, so I'll do that one, cancels out with that one. And this also doesn't involve h, so that cancels out with that. So all of those go to 0, and what I'm left with is 2xh plus h squared plus 4h, all divided by h. And then we can factor out an h, because every term in the numerator has h. So 2xh becomes 2x. H squared becomes h, and 4h becomes 4. And you can see if I multiply h by each one of those terms, I'll be back to where I started. And then I divide by h, the denominator. But now we have h divided by h is 1. So we're left with 2x plus h plus 4. So that's how these problems work out. Now in calculus, what we do is we make this h, which is the small step in the x direction, go to 0, and we're left with 2x plus 4. And it turns out the slope of the tangent line to this curve, x squared plus 4x plus 10, the slope of the tangent line is 2x plus 4. So I know the slope as a function of x. This process of letting h go to 0 is called the limiting process. But again, you'll see that in calculus. You'll see this difference quotient a lot.